back to Pepcoding. So the question which we will discuss today is called minimize malware spread to. So you've already done the first part of this question in the previous video, and if you haven't watched the video, I'll suggest you to go and watch the video first so that you can understand the basic concepts of this question better. Okay, so let us first read the question. It is given that you are given a network of n nodes represented as an n cross n adjacency matrix graph, where the ith node is directly connected to jth node if graph of I, j is equal to 1. That means that in your graph, at the ith, jth position, if you have 1, then I and j are directly connected to each other. Okay, some nodes initial are initially infected by malware. Whenever two nodes are directly connected and at least one of those two nodes is infected by malware, then both these nodes will be infected by malware. This means that let's suppose 1, 2 and 3 are connected to each other. If 1 is infected and 2 is directly connected to 1, then 2 will automatically be infected. Similarly, 3 will be infected because of 2. This spread of malware will continue until no more nodes can be infected in this manner. Suppose initial is the final number of nodes with malware in the network after the spread of malware stops. So initial holds all those nodes which have been infected. Okay. We will remove exactly one node from initial, completely removing it and any connections from this node to any other node. Okay. Now in the previous question what we were doing was we were simply disinfecting one node. In this case, what we are doing is that we are removing it from our graph and we are removing all its connections also. Okay. Then you need to return that if removed. The node that if removed would minimize initial. Okay. Now see. If I have a graph of this type, let's see. So 1, 4, and 5. Okay. Now let's say that from this graph, or let's add a few more components. In this, if I say that over here I am going to start with this graph and 0 is infected, then it will be able to infect the entire graph. Similarly, if 6 is infected, it will infect the entire graph and 9 will infect its entire graph. So now I need to prevent that from happening. So earlier what we were doing was we were simply disinfecting 0. In this case, I need to remove 0 as well as its connection. Now removing 0 and its connections is going to be easy. But let's suppose I had to remove 1 and its connections. Now if your idea was that we can create the graph first and then we can find out which will minimize initial and then we can remove it and its connections, that's going to be very hectic and very tedious. We can do this that while creating the graph, we will simply not add those nodes which were already present in initial, right? Let's suppose U was already present in initial, that means it is already infected. So I will not add it to my graph at all. Okay. And V denotes all its connections, so that connections will also not be added to my graph. This will really make the work easy for me. Okay. So let's try to do this by code and then side by side we'll discuss the rest of the part. So I've already copied the find function as well as the merge function. Okay. And I've copied these vectors which we created earlier because these are going to be exactly the same. Another part of the question which is going to be the same is the creation of graph which we did earlier. So I'm just going to bring that part over here and paste it. Okay. Okay. So this is the part which we've copied from our previous question, which was the creation of the graph. Now what I need to do is I need to remove or not add to the graph those elements which are already present in initial. So over here I'll create a set or hash set, right? A set of type int and let's name it s only. Then for auto e in initial, what I'm going to do, I'm going to add all the values to the set itself. So set.insert e. So this will get me a set of all those elements which are already present in initial. Then what I'm going to do in the graph, I'm going to make sure that those elements are not present in the graph. Okay, I'll not let them be added to the graph. So over here, I'll write st.find I equals st.end. Right, that means I is not present in the set, and st.find j is equal to here I have taken s, right? Yeah, that this is s. So s and this, here also it will be s dot. Okay, so this will make sure that I won't add all those elements which are already present in my graph. After that, I need to work with my parents. That is the unique parents. How am I going to work with them? So, see, this is a group. Let me just change the color. This is a group, this is a group, and this will be a group. So I need a representative of the group. Now the common parent or the unique parent of this group will be the representative for that group, right? For 2 and 3 I'll have a parent, for 4 and 5 I'll have a parent, for 0 I'll have a parent, and that will be the representative of that particular group. So I need unique parent, right? So for unique parent I'll work how? See, over here just so I can create a map over here. The map will be of the type int as well as a set of int. Okay, and let's name it mp. Okay, now in this when I'll work, so for auto u in initial, the first thing I need to do is I'll need to add this to my map. So how do I add this to the map? Set of int, okay, and mp of u will be equal to m. Okay, so it will add an integer u along with a new set to the map. Okay, after that I'll work for j. So for int j is equal to 0, j is less than n, j plus plus. Now what I need to do, I need to find my parent. So int p will be equal to, over here the function is parent, so parent of n. Okay, through this I will be able to find my parent, and this I need to add to my map. So I need to put it on my map. How will I put it on the map? It will be mp of u dot insert. But now this will be a little problematic. See why? Let's suppose I have the parent count to be greater than 2, greater than 1 for 0 and 5. Okay. Now what will happen in this case is that if it has the same parent and I remove 0, then 5 will infect my entire graph, and if I remove 5, then 0 will infect the entire graph. I need to make sure that the count of my parent should be 1. Okay, and only in that case, that means that if the parent is not already present in the map, only then I will add it to the map. So over here I'll create a vector which will keep my count. So vector of int infected, and its size will be n. Okay, and for adding it to the map I will check my condition. Okay, but before that, over here also I needed to work on a condition, right? What was the condition? That if graph of u and j is equal to 1 and u is not equal to j and the set does not contain j, that means in this case we will write s dot find j is equal to s dot end. Okay, then and only then I will find out my parent. So int p is equal to parent of n. Right. Now I need to work on the condition of adding it to the map. So what will be the condition? That if map of u dot find p equals to mp dot. Okay, this means that in my map the element u and and its related parent should not be present. Only then I will add it to the map, otherwise I will not add it to the map. Okay, so now mp of u dot insert p and infected of p will be incremented. Okay, now this part is done. Now I need to work with my answer and max, all the count which I needed to work with. So int answer will be equal to -1 and int max will be equal to -1 as well. Then over here I need to work with all my values in initial. So for auto u in initial, I already created a set of my parents right over here. I need not do this whole part again. So I will simply take a set of int, okay, and I will retrieve it from the map. So I'll name it as parents, and parents will be equal to mp of u. Okay, then after that I need to take a total variable and I need to work with my parents. So for auto p in parents, what I'm going to do, I'll check if the count in infected array is 1, only then I will add to the size, add to the total. So total plus equals to size of p. After this loop, my total will be having a particular value. I will check that if total is greater than equal to max, then in that case, if it is equal to max only, then I need to find out the minimum value, right? So answer will be equal to min of answer and u. Otherwise, answer will be equal to u. And we will initialize max as total, right? So after this will be done, I will have a value of answer also. Now I need to check that if answer comes out as -1, then in that case, it means it hasn't worked with this loop, right? So I will check if answer is equal to -1, then I need to give or return a minimum value. So I will take int minimum and I will initialize it as n+1. Okay. Now after that I will check that for each auto e in initial, mini will be equal to minimum of mini and e, right? And then I will return it. I will return minimum. Minimum. And if answer was not -1, then it means that it entered the loop and it has a certain value. So I'm going to simply return answer only. Okay, so this is my code for the question. I hope you understood the question. I will not be able to run the code for you since we are working on the test cases for you right now. Okay, but have faith, very soon you will be able to run this piece of code on the portal. Okay, till then, I'm going to request you to practice this question since we've already discussed the logic. Basics have been discussed in the previous question, and I'm hoping, I'm pretty sure that through this video you were able to understand the logic for this question as well as the piece of code which we worked on. Okay, so try to practice it on your own. Okay, and we will see each other the next time. Till then, keep practicing and please like, share and subscribe to our YouTube channel. Thank you.